In this video, I will show you how easy to make a 500 watt sine wave inverter, step by step in the details. This inverter's bare board is from the part of a mobile solar converter system recycled and in good condition. DC 12-volt terminal is here, and so is negative there. Those are the output of AC 230 volt. This socket is for a switch, which will turn the inverter on and off. Two of those sockets are for the cooling fans. Red indicator is for fault, and green indicator is for the power on and normal. A spare aluminium inverter's case is here, for this board, which has a good cooling fan within it. Inserting the board along here, however, it can't be fixed into due to the board is a bit of wide in its size. What I will do, by using a flat file to remove a bit of board edge, along this side. It has been done. Inserting the board by sliding it from here. The case's panel fixed a switch, and 3-pin AC socket is here. A couple of the heavy-duty wires have to be added between the case positive terminal and board positive, and so have negative. Added a couple of the wires between the case's 3-pin socket and output of AC terminals on the board as well. The original red and green indicators on the board will be moved to the area around there, to match two of the indicators' holes on the panel. All necessary works added have been done. Paying attention here, the board has been reinserted for putting the insulation tapes on both sides of the board to prevent from short circuit problem. They can be seen, the red twist wires connected between positive terminal from the case and positive on the board. Black twist wire connected between negative terminal from the case and negative on the board. That is a couple of wires for a cooling fan, which plugged into the one of the fan sockets. By facing this way, the positive and negative, which will be connected to a battery. A cooling fan is here. Incidentally, the cooling fan will not work until the heat sink's temperature reached 55 degrees Celsius, because of a 55-degree thermal switch, which attached around here at the bottom. The white and black twist wires are a couple of the wires from a switch here. The wire's other end has a plug, which has been plugged into the switch socket there. The original red and green indicators are still there, however they have been cut off from circuit board. A DIY made small circuit board here, which installed red and green indicators, has been connected from the original indicators circuit board, where they have been cut off. The one of the output of AC terminal on the board has been connected to the one of the pins from 3-pin socket, which is the yellow wire. The other AC terminal on the board connected to the second pin from 3-pin socket, which is the white wire. By facing this way, they can be seen, the on and off switch is here. Red indicator is on the left, green indicator is on the right. The 3-pin socket is here, and the earth pin at the bottom is not connected anything. Now put the case cover on its top. All done, and the case has been secured by screws. 500 watt indicated there is its standard power output. Connecting a pair of the battery's cables with alligators attached, by screwing the other ends of cables to the black and red terminals from the inverter's case. Now the inverter has been connected to a battery. The switch is here, turned it on, the green indicator is on, so the AC should be from the 3-pin socket there. A multimeter's AC position selected to measure the inverter's output voltage. Say, AC 233 volt without the load. The meter's 10 amperes position selected to measure the inverter's no-load current. It can be seen 0.23 ampere or 230 milliamperes. The inverter with the load and a mini oscilloscope have been set up. A multi-socket set plugged into the inverter's output socket, then 3 bulbs and mini oscilloscopes accessory plugged into the multi-socket set as well. That is the voltage divider connected with the scope for safety operation. Switch the inverter on. A 50 Hz sine wave has been showing from the inverter's output AC socket. A multimeter's AC voltage position selected, instead of a mini oscilloscope. The meter has showed, say, AC 240 volt with the load. Disconnected the battery now. This easy-made sine wave inverter can be almost used for any home appliances, such as home light bulbs, phone charger, fans, laptop, and desk computers, etc. Its power capacity is 500 watt standard. Make sure to have enough buffer under its wattage. It is light, compact, and durable. How long does the inverter last? Well, the inverter itself has no problem. It depends on the battery capacity. Generally speaking, with good condition battery, the bigger in its size, the longer. Now you've seen how easy a sine wave inverter has been made. Thank you for watching. Please like, share, comment and subscribe if you have enjoyed the video. Your encouragement is my motivation.